Good evening, everyone. Hope you all are doing good. Whosoever is live, please once confirm, is audio and visibility clear? Is audio and visibility clear? Once confirm. Okay, nice. So today what we are going to discuss, the important topic of the strength of a material, that is the introduction to stress and strain. So let's proceed. This is all about me. I have done M.Tech from NITJ and my achievements are I'm 2 times GATE qualified and M.Tech gold medalist. Okay, so I have taught geotechnical engineering, surveying and strength of material, environmental engineering and irrigation and hydrology. So today we are going to discuss what is stress and strain. Basically, first of all, what we are going to discuss is what is strength of material and engineering mechanics. Do you people know what is SOM and engineering mechanics? Do you people know what is SOM and engineering mechanics? Come on, answer fast. So, let me tell you the difference between the SOM and the engineering mechanics. So let's see. So you can understand that SOM and engineering mechanics both are the part of the mechanics. They are the branch of mechanics. Okay? They are basically both the branch of mechanics. Now, where does the difference lie then? Where does the difference lie then? It lies in the study of the forces as well as the consideration of the body, as well as the consideration of a body. In SOM, what we study? We study the internal forces and the stresses. We study the internal forces and the stresses. And in engineering mechanics, what we study? Here we study the external forces. Here we study the external forces. So in SOM, we study the internal stresses, and in engineering mechanics, we study the external forces. We study the external forces. Okay, is this point clear? Is this point clear? Now, the second difference lies in the type of body. In SOM, we consider the deformable bodies. We consider the deformable bodies. And in engineering mechanics, we consider the rigid bodies. In engineering mechanics, we consider the rigid body. So, ma'am, we don't understand this deformable body. We don't understand this rigid body. Please make this thing understandable to us. Please make this thing understandable to us. So, right, the deformable body is the one. It is the one which undergoes the change in the geometry of a body when load is applied. Right here, the deformable body, it undergoes change in geometry of a body, change in geometry of a body when load is applied. When load is applied. Okay? So let's understand this with an example. Here is a body and 2 points. Let's take 2 points A and B. Let's take 2 points A and B. and we are exerting a load on a body. What happens in a deformable body? What happens in a deformable body? If the distance, let's suppose it is x in between A and B, what is happening in deformable body? After load is applied, what happens? These 2 points are not at a distance x, they are at a distance x1. That means their distance between the particles A and B is changed now. So it's called as a deformable body. So now can you understand what is rigid body? Did you understand what is deformable body? Did you people understand what is deformable body now? Okay. So, when we talk of the rigid body, what is happening there? Let's suppose these are the 2 points A and B and the distance between them is x. When we are exerting a force, let's suppose P on a body, what is happening there? The distance between A and B is not changing. It remains same despite we have applied a load on this body. So this distance remained unchanged. So this is called as rigid body. Is this clear to all? Is this thing clear to all? So rigid body is a type of a body which doesn't undergo change in geometry when external force is applied or when load is applied. Is this thing clear now? What is deformable and rigid body? Okay. Now, first of all, I will make you people understand that if I am applying a load, let's suppose P on a body, it will either deform, that is change its shape, or there will be no deformation, there will be the production of acceleration or a velocity. So, when external load is applied and the body deforms, what we are going to discuss that time? What we are going to study that time? We are going to study SOM at that time. So, in this subject, what we have to discuss now, we have to discuss the change in the shape of the body, that is the deformable body, in resistance to the external load. Is this clear to all? See this figure now. See, let's suppose I'm applying a load P on the surface. If this surface is deformable, that is, we are talking of SOM. Isn't it? So, when I apply a load P on this body, what will happen? This body will give me the internal resistance. This body will offer a internal resistance in response to this external load. So, this internal resistance that is caused by the body in response this in response to this external force, it's called as stress. It's called as stress. Okay? Clear this point? Is this point clear? So let's move on to now, what is basically a stress? What is basically a stress? What do you understand by stress? Very nice. What do you understand by stress? Does anyone know what is stress? So you can understand the stress by this example. See this body, this is a bar. We are exerting a force P on this body. We are exerting a force F on this body. When we cut this body at the center, I can see the cross section. I can see the cross section of a body, isn't it? And there will be the internal resistance. There will be the internal resistance in opposite direction to the force applied. In opposite direction to the force applied. This internal resistance will be same as that of the external force. Let's suppose I will take this internal resistance as R. I will take this internal resistance as R, and this internal resistance will be equal to external force. It will be equal to external force. So the denotion of a stress is denoted by, keep this thing in mind, it's denoted by sigma. It is denoted by sigma. Okay? It is denoted by sigma. And it is equal to F divided by area. F divided by area. What is this F now? This is the internal force. This is the internal force that is generated in response to the external load. That is generated in response to the external load. And what is this A? This is the cross-sectional area. This is the cross-sectional area. Got this point? Got this point? Clear? Is this point clear? So, as I told you that internal force, this internal force R is equal to F. I can write here F divided by A as internal force is equal to the external load that we have applied. Clear? Clear? So, stress are generated as a resistance to the applied external load. These are generated as a resistance to the external force that is applied on a body. Okay? So now tell me, what is the unit of stress? Can you people tell me what is the unit of stress? Now this is simple. What is the unit of force? What is the unit of force? You all know it is Newton. And what is the unit of area? It is meter square. Can I write the unit of stress is Newton per meter square? Newton per meter square. Okay? Is it clear? So right here I can write its unit is Newton per mm square. Its unit is also Newton per mm square. Or can I write the unit of stress is kilonewton per meter square? Can I write unit of stress is kilonewton per meter square? So in the denominator what we have? We have the unit of area, and in numerator what we have? We have the unit of force. In what unit you want to convert it, you can convert afterwards. Okay? So yaad rakhna, keep this thing in your mind that Newton per mm square, it is megapascal. It is megapascal. And Newton per meter square is pascal. It is pascal. Okay? Okay, clear? Can you people tell me now what is the dimension of stress? Dimension of stress. What is the dimension of Newton? You all know it is m power 1. It is m power 1 L power 1 T power minus 2. And the unit of area, what is it? बता दो dimension of area, it is L to the power 2. So can I write here it is L to the power minus 2? Can I write here it is L to the power minus 2? Can I write then dimensional formula of stress is M power 1 L power minus 1 L power minus 1 and T power minus 2. Isn't it? Is this thing clear? Is this thing clear? Yes, ma'am. Absolutely clear. Absolutely clear. Very nice. Very good. So, now we have completed what is stress. Let's see now what is the simple stress and strain. What is simple stress and strain? As I have already told you what is stress. Now let me discuss what is strain now. I will tell you strain here in brief. After that we are going to discuss strain in detail. Till then you understand what is strain. Strain is change in dimension of a body to the original length. Change in dimension of a body to the original length. Okay? And one important point you should note down here is that which one among the stress and the strain is the fundamental quantity? Which one? Write down here. Write it as an important point. Important note here is that strain is the fundamental quantity. Strain is fundamental quantity which we can measure. Fundamental quantity basically which we can measure. And stress is the derived quantity, and stress is derived quantity and is function of strain and is function of strain. As I have discussed strain in brief here, you should also note down here that strain is denoted by epsilon. Strain is denoted by epsilon. So, I have told you stress is denoted by sigma and it is the function of epsilon. It is the function of epsilon. So, you people can write it like this. You people can write it like this. So, you all know as we denote the fundamental quantity. We denote the fundamental quantity on the x-axis. So strain always is denoted on x-axis. It is always denoted on x-axis as it is a fundamental quantity. And derived quantity is which one? Derived quantity is which one? With stress. Derived quantity is stress, which is derived from the strain. Okay, we get the stress from the strain. So it is denoted on y-axis. You will always find stress on the stress on the y-axis and strain on the x-axis. Okay, is this clear? Is this clear? Everyone, write in a comment section, is this clear? Have you any doubt till this point? Anyone having any doubt till this point? Okay. Okay. So, Let me make you people understand here. First of all, what is the difference between the stress and the pressure? What is the difference between the stress and the pressure? Can you people tell me what is the difference between the stress and the pressure? Always remember this point. Always remember this point. Stress, we write as force per unit area. Pressure, we write as force per unit area. Ma'am, then where does the difference lie? You people should remember that the difference lie in whether the force is external, or internal. When we talk of the stress, you all know we are talking about the internal stress. We are talking about the internal thing. And when we talking about the pressure, it is something exterior. It is something external to the body. So when we are applying pressure, where we are applying it, we are applying pressure external to the body, and stress is something that is generated internally, within the body. So this is the stress, and pressure is exterior. Pressure is external, we can say. Okay, is this thing clear? Any doubt? Okay, so let me add slide first. Wait a second. I will write it here so that it will be clearly visible. Wait a second. So write it here. Write it here in the important points that important point so first of all, we are going to discuss what is pressure. Pressure, you all know, it's force per unit area. But the pressure is measurable. It is basically measurable. And the pressure is external to the body. It is always external to the body. We are applying the pressure externally. Like our body, if I am applying pressure, we will apply pressure external to the body. After that, when we are talking about stress, this is basically the force per unit area. But here it is the internal force, and we are talking about the stress when we considered it interior to the body. That means this is the internal resistance that is generated by the body in response to the external force. But in pressure, here it is the external force per unit area. Here the pressure is the exterior thing and the stress is the interior thing. Is this clear? Very nice. Pressure is measurable. Exactly. Very good. Till this point, any doubt? Anyone having any doubt? Come on, fast. Tell me fast. Okay. So, Wait for 2 minutes. Thank you for your cooperation. So, see now, we have discussed the stress. Now, before discussing the type of a stress, we people may understand what is the longitudinal axis and what is the lateral axis. Do you people know what is longitudinal axis and what is lateral axis? So let's see. So let's suppose I'm applying a load P in x direction. Okay, I'm applying load P in x direction on a body. This you know it's x direction, x axis, and after this is your y axis and this is your z axis. So understand now, if I am applying a load in the x-axis, this axis will become the longitudinal axis. This axis will become the longitudinal axis. Okay? And y-axis and z-axis will become these two directions will become the transverse directions. These two directions will be the transverse or lateral axes. So here I can say x-axis here is longitudinal axis. So x-axis is here a longitudinal axis. So how can you define now longitudinal axis? It's the axis along which load is applied. Okay, clear? Tell me now, what is lateral axis? Now this thing will be clear to you people, that lateral axis or transverse axis, we can say it is y-axis and z-axis. And let's define now what is this lateral axis or the transverse axis. Axis is the axis that is perpendicular to the application of load. Is this thing clear? What is the longitudinal axis and what is lateral axis? Okay, very good. Very nice. Simply very good. Now, longitudinal axis and the lateral axis is clear to you people. Now, we will see now what are the types of stress. So, stress is classified into two types. We can say it is classified into two categories. One is the normal stress and another one is shear stress. Okay, one is normal stress and another one is shear stress. So by this figure, can you understand what is normal stress? And by this figure, can you understand what is shear stress? Can you find the difference between the two? Can you people find the difference between the two? Yes, visibly it is clear. You can find the difference. That normal stress is applied. Normal stress is applied normal to the cross section. It acts normal to the direction of the cross section. Okay, it acts in the perpendicular direction to the cross section. And shear stress, what is the direction of the shear stress? Can you people see what is the direction of the shear stress? Yes ma'am, it's the internal resistance that is offered by the body against the shearing force in tangential direction. It is basically in the tangential direction or parallel to cross section. Right here, normal stress is acting perpendicular to direction of cross section. And the shear stress is acting, where it is acting? It is acting parallel or in tangential direction to cross section. Clear this point? Very nice, very good. So right here, what is normal stress? I will make you people understand now normal stress in detail. Okay? Okay. Let's understand now what is normal stress. As you can see in this diagram, what is happening? This internal resistance is occurring inside the body and it is occurring in perpendicular direction to the cross section. Isn't it applying perpendicular? Isn't this resistance occurring perpendicular to the direction of cross section? Cross section is like this. and internal stress is occurring perpendicular to this direction. Yes, ma'am. So basically, what does it denote? It denotes the normal stress. And here you can see the internal resistance is parallel to the cross section. This is a cross section, and this internal resistance is parallel to the cross section. And so you can understand the difference between the normal stress and the shear stress by this diagram. Yes, ma'am. Now this is easy for us. So write down the definition of normal stress, my dear students. Write down the definition of normal stress. So write the normal stress is the stress which acts normal to the cross section normal to the cross section at any section. It has also got two types. It is further classified into two types. One is the direct normal stress, and indirect normal stress, which is called as bending stresses. Indirect normal stress, which is basically called as bending stress. So I will show you people in detail how this is direct normal stress and how indirect normal stresses come through bending stresses. First of all, you people write what is the shear stress. Okay, write it here so that it will be clear to you all. Shear stress. Write down the definition. The resistance offered by a material against shearing force and it occurs in which direction it occurs? Come on, tell me fast. In which direction it occurs? Come on, reply fast. Very nice. Shear stress acts. Very good. Shear stress, you all are right. Shear stress acts parallel or tangential to the surface. Parallel or tangential to surface. Is this thing clear? Very nice, very good. So it is further classified into two: direct shear stress and bending shear stress. Okay, not bending shear stress, indirect shear stress, sorry. It is direct shear stress and indirect shear stress. And this indirect shear stress here, I will add a slide, wait a second. So write down here that shear stress is further classified into two. One is direct shear stress and another one is indirect shear stress, and another one is indirect shear stress. As I have told you already, normal stress, in normal stress, indirect stresses are created because of the bending stresses. So in shear stress, you should keep this thing in mind, that the shear stress, indirect shear stress, are generated because of the torsion. Okay. Here the stresses are created, normal stresses are created because of the bending, and the shear stresses, indirect shear stresses, are created because of a torsion. Okay, is this point clear? Let's discuss now normal stresses and shear stresses in detail. Okay, ma'am, tell us, what are now the direct stresses, direct normal stresses? Also write here one point. You should write here, the normal stress are the stresses, yes, they act normal to the cross section. Okay, it's correct. Yeah, one another point here is, it is denoted by sigma, and here the shear stresses are denoted by tau. Keep this thing in mind. Let's understand now direct normal stresses and indirect normal stresses. Are you people ready? Tell me once how energetic you people are. Tell me how energetic you people are. Tell me fast. Okay. So let's start. You all are ready now? So let's start. So let's discuss at first direct normal stress. So see, when I am applying the external load, let's suppose P on a body, and this P is, you can see, this is tensile. As I am pulling the body, this force is, here the force is shown as a tensile force. This is the tensile force that I am exerting on a body, and here you people can see the difference. Here we are applying the compressive load. What here we are doing? We are exerting a compressive load on a body. A usual denotation is that we denote tensile with a positive sign. And compressive, now tell me, compressive will be denoted as, it will be denoted by a negative sign. Let's suppose I am writing plus P. You people should understand it is a tensile load that is acting on a body, and if I am writing minus P, you should understand that I am applying a compressive load on a body. Here now, my main focus is to make you understand now what is this direct normal stress. The internal resistance that is offered by the body in response to this external tensile load is called as tensile stress. So direct normal stress can be of tensile nature or compressive nature. Okay, so direct normal stresses can be tensile or it can be compressive. Depending upon which now it depends. It depends upon the type of external force we are applying on a body. It depends upon whether the normal stress is tensile or compressive, will depend upon whether we have exerted a tensile load on a body or we have exerted a compressive load on a body. So if we will apply a tensile load on a body, then the stresses generated will be of a same nature. That will be the tensile. That will be the tensile. Write it down here. Important point. If I have applied tensile load on a body, stresses generated will be, come on, answer fast. Answer fast now. Stresses generated will be tensile in nature. Very good, everyone. Very nice. Everyone has given correct answer. Stresses generated will be tensile in nature. So, you people are getting this concept. Very nice. So, when the load exerted on a body is compressed, you tell me which type of stresses will be generated. So, stresses generated will be compressive in nature. Very good, everyone. Very nice. You all are getting this concept? So, it is enough. Okay. So, is this clear? So, these are the direct normal stresses. These are the direct normal stresses. Now, I will talk about what is the bending normal stress. What is the, I can say, bending stress. Bending stresses are the indirect normal stresses. Write it down here. Bending stresses are indirect normal stresses are generated. Indirect normal stresses are generated. Now you all know what are the normal stresses. What are the normal stresses? You know it can be of a tensile nature. It can be of a tensile nature or it can be of a compressive nature. Same will be understood here. Same will be understood here. Like let's suppose bending occurs in any body. Let's suppose this is a body. Let's suppose this is a body and I'm applying a transverse load on a body. Let me redraw this. Let's suppose this is a body and I'm applying a transverse load P on a body. I'm applying transverse load P on a body. What is happening there? As I have told you already, in SOM, we talk about the deformable body. So, deformation will occur. So, here bending will occur. Okay, ma'am. Nice. We have got this concept. See this point now. What I have told you, normal stresses are of either a tensile nature or a compressive nature. So you can see here when a load is applied on a body, what is happening? The particles here are exerting the compressive load. Here these particles are exerting compressive load. You can imagine this diagram. See, I'm bending something. I'm bending an object. You see the upper particles, they are coming close. That means there will be the compression, and the lower particles and these are moving apart. These are moving far. So here tensile stresses are generated. Got this concept? So these basically are the compressive stresses generated here and the tensile stresses generated at the bottom. These are basically the indirect normal stresses. Got this? So what do you understand by now? Direct normal stress. I told you normal stresses are of two types, whether it can be tensile or compressive depending upon the external load I have applied on a body. If directly I'm applying a load on a body and the stresses generated here, whether tensile or compressive depending upon the direction of the external load, that's called as the direct normal stress. And here indirect normal stresses are generated because of bending, and here these indirect normal stresses can be of tensile nature or compressive nature depending upon whether I'm talking about the load that is bending the beam in which direction. See now, when I'm talking about the cantilever beam, see now here, okay? Keep your mind here. When I'm talking about a cantilever beam, what is happening there? I'm showing here a bending diagram. Let me draw a diagram initially. How was a cantilever beam? Okay, before applying a load. So now when I have applied a load P on this cantilever, what is happening here? What is happening here? The upper particles are moving. They are moving far apart. They are moving far apart. That means there is the tensile stresses occurring in the upper part, and you can see here the lower portion particles are coming close. So what will be here? What will be here? Which type of stresses will be coming here? The stresses will be of compressive nature. So here, depending on the type of a beam, does this compressive and tensile directions change? Yes ma'am, obviously ma'am. Is this concept clear to you all? Is this concept clear to you all? Okay, very nice, very good. So after this, let's understand now what is this shear stress. What is the shear stress? As I've already told you, is the resistance offered by the body against the shearing force, is the internal resistance offered by the body against the shearing force. And I have told you that the shear stress is classified into the two, same as I have classified the normal stress. Shear stress is classified into direct shear stress, and we have indirect shear stress. We have indirect shear stress. Okay? Okay? And this direct shear stress is produced due to the direct shear force. Okay? Direct shear stress as as direct normal stress was generated by the direct application of the load, and here the direct shear stress is produced due to direct shear force. It's produced due to direct shear force. And now tell me how this indirect shear stress will occur. Tell me how this indirect shear stress will occur. So indirect shear stress will occur, it will be produced when torsional moment or a torques act on a member. When a torsional, write down here, when a torsional moment or torque acts on a member, when a torque acts on a member, that time indirect shear stress is generated. See, in this diagram, what is happening? Here we apply a torque. Can you see internally a resistance is generated. In response to this torque. This is called as the indirect shear stress. Is this clear now? Okay, so one thing right here, direct normal stress is also called as axial stress. Write it down here. It's also called as axial stress. Okay. So Till this, is everything clear? Is anything to be repeated? Is anything to be repeated? Will we discuss strain today, or we will discuss it on another day? Okay, we will discuss it tomorrow. Till then, solve this question as I have told you about the stress. Solve this question. After that, we will end this class. See, a punch of 20 mm diameter is used to punch a hole of 8 mm thick plate. If the force required to create a hole is 110 kN, the average shear stress in the plate will nearly be equal to. Come on, answer this question, everyone. As I have told you what is the shear stress, you people should now be able to solve this question. Answer the question fast. Answer this question fast. Okay, very nice everyone, very good. You people are rocking, absolutely nice. So, you know average shear stress is equal to force per unit area. It's force per unit area. What is force given here? It is given 110 kilonewton. It's given as 110 kilonewton. Okay, write it first like this. After that, we will see the conversion of a units. Now, see, what is the area? What is the area? You all know area is equivalent to perimeter multiplied with thickness. What will be perimeter here? It will be 2 pi. And thickness will be as such what is given there. Isn't it? Okay, perimeter will be pi d. Okay, pi d, and it will be multiplied with 2t. Okay, very nice. Pi multiplied with t. What is t? It is 8 mm given, isn't it? It is 8 mm given, so write it here, 8 mm multiplied with what is d? What is d? It is 20 mm given. So don't change the units, write it as such as it is given. So what is it coming out to be? It is coming out to be 160 pi mm square. Pi mm square. So let's substitute it here, 160 pi mm square, as we have given answer in MPa, that is megapascal. Do you know what is MPa? Yes ma'am, we know it is equal to 1 Newton per mm square. So convert numerator in convert numerator in Newton. Can you people convert kilonewton in Newton? Ma'am, what are you talking? What are you talking? We can. This is the basic conversion. So convert fast and give me the answer. Convert fast, give me the answer. So this Newton per mm square is Pascal, is answer coming out to be 220 Newton per mm square. And can I write Newton per mm square as MPa? Can I write Newton per mm square as MPa? Yes ma'am, absolutely. So which among of you has given C option as their option? They are absolutely correct. Very nice, very good. So this is all about today. Anyone having any confusion, they can ask. Very nice, very good. Everyone has given correct answer, means you all have got this concept. Okay, very good. Very nice. So whosoever don't have any confusion, they can leave the class. None of you having the confusion? Okay. Okay, thank you very much. You all can leave the class. We will meet in another session tomorrow. Thank you.